Hello again. This is section 10.9, Systems of Inequalities. So what we're going to look at in this section now is what happens if we have multiple inequalities that we're trying to graph. And these can be linear, they can be nonlinear, but we're going to look at how to graph inequalities first, and then what happens if we have a system, a series of them that we're actually graphing together. How do we find the solutions then to those systems of inequalities? All right, so first off, just to graph an inequality, we're going to carry out these steps. The first thing we're going to do is we're going to consider it as an equation and just think about what the graph of that would look like. Now, if there's a greater than or a less than symbol, then we're going to use a dashed line for that part of the curve. If there's a greater than or equal to or less than or equal to, then we're going to use a solid line to graph that part of the curve. Okay, so just keep in mind greater than and less than, dashed, greater than or equal to, less than or equal to, we have to make solid. At that point, we're going to look then and we're going to graph the inequality piece of it. So we're basically going to choose a test point somewhere on our graph, and we're going to figure out, does that point actually satisfy the inequality or not? And then if it does, then we're going to shade everything in the direction of that point. And if it doesn't actually satisfy, make the inequality true, then we're going to shade everything away from that point instead. All right, so let's take a look here. We're going to graph each one of these inequalities separately. We've got x squared plus y squared less than 25. So the first thing we want to do is think of it as an equation. Well, if this was x squared plus y squared equals 25, this would be the equation of a circle. We would have a radius of 5 because we would take the square root of 25 to get our radius. And because we're not adding or subtracting anything to the x and y, our center would be at 0, 0, at the origin. So I'm just going to start here by thinking of this as a circle with the center of my circle at the origin and a radius of 5, which means I need to go out 5 in all directions. I have a point here at 5, 0, 0, 5, negative 5, 0, and 0, negative 5. Now, when we actually graph the circle, we have to consider whether it's going to be dashed or solid. Since this is a less than, not a less than or equal to, we need to make sure that our circle is dashed. So just make sure when you graph your circle here, you're going to use a dashed curve to represent this circle. And circles aren't the easiest thing, so just do your best if you're ever asked to graph a circle here. All right, now the last piece is to actually think of it as the inequality now. So x squared plus y squared less than 25, we're going to choose a test point on our graph, and we're going to see if it actually satisfies the inequality. Well, in this case, as long as you choose something that's not on the curve itself, something anywhere else on the graph, that's fine. 0, 0 is not on the curve, so I'm going to go with 0, 0, and I'm going to substitute it in. So we'll do 0 squared plus 0 squared. And we're asking ourselves, is that less than 25? Well, 0 squared plus 0 squared is 0, less than 25. And in this case, yes, 0 is less than 25. This is a true statement, which means that we want to shade everything towards the point 0, 0. Well, that's the origin, so that means we're shading everything inside of our circle this time. We're going to have this dashed circle, radius of 5. And everything inside that circle now is going to be shaded. Now, if instead we had gotten a false statement when we plugged in that value, then we would actually shade everything away from 0, 0, meaning we would have shaded everything outside of the circle instead. So it doesn't matter what point you choose, you're just trying to see, does it make it true or not? If it makes it true, shade that point. If it doesn't make it true, then shade everything away from that point instead. Right, now our second inequality, we have x plus 2y greater than or equal to 5. First thing we're going to want to do here is get this into slope-intercept form so that we can actually think about what the graph looks like. So I'm going to move my x over. I have 2y greater than or equal to negative x plus 5. And then I'm going to divide by 2. And when I do that, I have to divide every single term. We get y still greater than or equal to, because I divided by a positive value, negative 1/2 x plus 5 halves. So now we know the slope and we know the y-intercept. So now we can actually graph this. This is going to be linear. I'm going to locate my y-intercept first. 5/2, same thing as 2.5. So I'm going to go up 1, 2, halfway between 2 and 3. My slope is -1/2, which means I'm going to go down 1 and to the right 2. Down 1, right 2, puts us right in here. And now we need to look at whether this is going to be a dashed line or a solid line. Well, this one is greater than or equal to, so we know it's going to be a solid line. So I'm just going to make a solid line through those 2 points now. So that's the first step, actually graph the equation. Now we're going to choose a test point, and we're going to see if it makes it true or not. So again, I'm going to use 0, 0 again just to see what happens. I'm actually going to go back to the original up here just because it's going to be easier to substitute in there. You could plug it in either place, though. It does not matter. We can do 0 plus 2 times 0. And we want to know, is that greater than or equal to 5? Well, again, when I simplify the left-hand side, that's just going to give us 0 greater than or equal to 5. In this case, 0 is not greater than or equal to 5. This is not a true statement. So that means I need to shade everything away from 0, 0. So if I do that now, that means I'm going to be shading everything up and to the right of that line this time. Now, the more of these that you do, you might get familiar with just, because this came out as y greater than or equal to this line, that means it's going to be everything above. And you might not even need to do those test points anymore, right? And that's perfectly fine. If you're ever questioning which way you're going to shade something, just choose a point somewhere that's not on the curve or the line itself, plug it in, see if it's true or false. If it's true, shade towards that point. If it's false, shade away from that point. Right now, a solution to a system of inequalities. So to graph a solution to a system of inequalities, we're going to do these 3 steps. Number 1, we're going to graph each inequality, right? Just like we did on example 1. Then we need to graph the solution of the system, which means we're going to shade the region where the graphs of all inequalities intersect. In other words, we're only looking at the overlap of whatever those regions are. So once we actually graph all these things together, we're only going to look at the overlapping region. That's going to be our solution then. And then the last step is we can find vertices, which are just the points of intersection of the boundary region that we're actually looking at that point. All right, so this time we're given the exact same 2 inequalities that we just looked at, but now because of the brace, we know this is now a system of inequalities, which means we're going to graph them together, and we're going to try to find the overlapping region because that'll be the solution then to that system of inequalities. Now, since I already know what these look like, based off the previous example, I'm going to go ahead and graph my circle first. So we'll go 1, 2, 3, 4, 5 in all directions. So I have these points here. Like we said before, because this one is strictly less than, we know it's going to be dashed. So I'm going to make my circle dashed. And then we said this one, because it was less than 25, once we plugged in 0, 0, that was a true statement. And that meant we were shading everything inside this circle. Okay. Now, on the same graph, I'm going to graph the second inequality. That was our line. Actually going to change colors here so that we can distinguish between the two. So we're going to go up 2.5 because that was our y-intercept. We're going to go down 1 over 2. And then we're going to sketch our line through those 2 points. So we end up with a line that looks something like this now. And remember, this one was solid because of the greater than or equal to. And then we said we need to shade, and this one, when we shaded, was everything above that line. So when we plugged in 0, 0, that gave us a false statement. We shade away from 0, 0. So that's everything up here now. Now, once we do that, that is not our solution, okay? Because remember, it said once we graph the two inequalities, we only want to find the overlapping region between the two. So now I'm going to do a separate graph where I only graph the actual solution to this system. Well, in this case, I still need my circle and I still need my line. So I'm going to go ahead and graph both of those. And then we graph our line, which was 2.5, down 1 over 2. It was like this right here. Now, at that point, we only want to find the overlap. Well, in this case, the overlap is that top right portion of our circle where it actually overlaps between everything greater than the line and everything less than the circle. So the only thing that gets shaded in our final answer for our solutions this time is this region right in here. So just be careful on problems like this. Right? We're not shading everything from both graphs. We're only shading for our final answer the overlapping region of the two inequalities now. Now, the last piece is we want to find the vertices. Like I said, those are going to be the points of intersection that are boundaries of the region that we shaded. In this case, we're going to have one point up here where the line and the circle intersect, and this other point down here where the line and the circle intersect. Those are going to be our vertices. To find those, we're going to use some algebra, and we're actually going to do this either by substitution or elimination. This one we cannot do by elimination because the first inequality has x squared and y squared, and we don't have an x squared or y squared in the other. So we're going to have to use substitution in this case. I'm going to think of these as equations at this point, and I'm just going to solve this first one, or sorry, the second one for x. So I have x plus 2y equals 5. I'm going to move my 2y, so that gives us negative 2y plus 5. Now I can substitute that into the first inequality. Again, I'm going to think of it as an equation to actually find the points of intersection. So if we do that, we're going to have negative 2y plus 5 squared plus y squared equals 25. Now we can solve this for y. I'm going to square this first part. Remember, that's going to use FOIL when we do that. So it becomes 4y squared. We're going to get a minus 20y when we combine middle terms, and then plus 25 plus y squared equals 25. Now, combine like terms. I'm going to move the 25 to the other side, and that's going to cancel. I can combine my y squares, so we get 5y squared minus 20y equals 0. Now we factor. We have a common factor of 5y. Factor that out. That leaves us with y minus 4. And now if we set each one of those factors equal to 0, that's going to give us our 2y values. So 5y equals 0, and y minus 4 equals 0. Dividing by 5 gives us y equals 0. Adding the 4 gives us y equals 4. Remember, we're still not done because we still need to go back and find the x values that correspond to those y values. I'm going to plug in the 0 and the 4. The easiest place to do that is right here since we've already solved for x. So we'll have x equals negative 2 times 0 plus 5. And when we simplify that, that just gives us 0 plus 5, which is 5. And then the other one's going to be negative 2 times 4 plus 5. That's negative 8 plus 5, which should give us a negative 3. So now when we actually label these points, The one over here now, when I plugged in the 4 for the y value, I got -3 for the x. So that point is going to be -3, 4. And then the other point, when I substituted 0 for the y, I got 5 for the x. So that point is going to be 5, 0. So those are the two vertices now for that system of inequalities. Now, in this case, these came out as nice integer values. So you could have actually put this into Desmos, looked at the graph, found the points of intersection that way. So using the graphing method is perfectly fine as long as you can get an exact value. There will be cases, though, where we get radicals, square roots, those types of things that are irrational values, and you won't be able to get an exact value from your graph. So you're going to need to know how to do this algebraically to find those points of intersection in those cases. All right, example 3. So again, we want to graph the solution set of this system. This time we've got 4 inequalities to look at, though. Okay, so again, first thing I'm going to do, I'm going to get these first 2 in slope-intercept form so I know what they look like. So I'm going to go ahead and move my x over. I'm going to divide by 3. And so that's my first inequality. If we take the second one now, I just need to move the x over. And so those are the 2 inequalities we're going to start with. And then the other 2, x greater than or equal to 0, we can graph that. And y greater than or equal to 0, we can graph that also. All right, so again, we're just going to graph all of these together first on the same graph. So we'll start with the first one. We have a y-intercept of 4, a slope of -1/3. So I'm going to go up to 4. I'm going to go down 1 and right 3. So down 1 to the right 3 puts us right here. In this case, it is linear, and because it's less than or equal to, it's going to be a solid line. So I'm going to go ahead and do a solid line between those 2 points. In this case, this one is less than or equal to. So again, if you get in the habit of saying, well, that means it's going to be below the line, that means we're going to shade everything down and to the left. Or if you want to substitute in a point, in this case, 0, 0 works. If I plug in 0, 0, that indeed is less than or equal to 12 initially. So I know I'm going to shade everything towards 0, 0. And that's going to give us everything down this way now. So that's our first inequality. Switch colors and we'll do the next one. Okay, so now I'm going to graph the y less than or equal to -x plus 8. So I need to go all the way up to 8 this time. Give us a point up here. Slope this time is -1. It's like -1 over 1. So I'm going to go down 1 over 1. 1 over 1 puts us right here. So now I'm going to sketch this line. Again, it's going to be a solid line because of the less than or equal to. Solid line that goes through these 2 points here. Something like that. And again, if I substitute in a point, 0, 0 works again. 0 plus 0 is 0. That is less than or equal to 8. So I'm going to shade everything towards 0, 0, which again is just everything below this line. All right, now we need to graph the x greater than or equal to 0. Well, x equals 0 would just be a vertical line along the y-axis because that's where x is equal to 0. Greater than or equal to, then, we're going to shade everything to the right of that because that would mean we want it to be positive. I'm just going to shade everything to the right of the y-axis this time. You can see our graph starting to get a little messy, right? So try to kind of keep in mind as you go, where are these regions actually overlapping? Because that's going to be the solution that we want in the end now. And then our last inequality, we want y to be greater than or equal to 0. Well, y equals 0 would be a horizontal line at 0. That's the x-axis. Greater than or equal to 0 then means we're going to be above that. So I just need to shade everything above the x-axis this time. So that takes care of all of our inequalities. And again, that is not our solution, because the solution now is only the overlapping region of all of the inequalities together. I've got to try to figure out, where do all these colors actually overlap? Well, if we look, we know we want to be to the right of the y-axis, above the x-axis, and then below those two lines. The only place where I have all of my colors now is this region right in here. And so there's kind of a quadrilateral area there, right, with the four sides, where all of those colors come together to the right of the y-axis, above the x-axis, and below both of those lines, the red line and the blue line. So now, when I actually sketch my solution, I know my y-intercept over here was at 4, so I'm going to go up 4. I will point there. In this case, if I were to think about where the red line intersects the x-axis, I would basically just substitute 0 for the y value, and that would give us x equals 12. So that means my x-intercept is all the way out at 12. And then the other piece we would need is the point of intersection of the red line and the blue line over here, so that we know exactly where we need to actually adjust that region. And so in this case, I'm going to go ahead and find that. That's just finding the point of intersection between the two inequalities that we had up at the top. Substitution or elimination would work here. I'm actually going to use elimination because I see I can just cancel out the x values by subtracting the two equations. So if I just take this equation now and subtract it from the top one, that's going to give us 3y minus y, which is going to be 2y. 12 minus 8 is 4, and that means that y has to be equal to 2. Then we can substitute that back into either one of our equations or inequalities. So I'm going to plug that in for y in the second one. That's going to give us x plus y equals 8. So x plus 2 equals 8. Subtract the 2, so x equals 6. So 6, 2 is that point of intersection now. So I'm going to go over 6, up 2. And that's where that region is actually going to change. So basically, this line is going to come down like this. And then the red line comes down like that. As long as everything's to scale, you'll see that these aren't exact, they're not the same slope, right? So they shouldn't be just on a single line, but it should be pretty close in this case, right? One has a slope of -1/3, the other has a slope of -1. And then again, we're only shading the overlap now to the right of the y-axis, above the x-axis, and below those two lines. So our actual solution this time is this whole region down here now. Now, in terms of vertices, we're actually going to have 4 vertices that we need to find. One of them we already found, right? So the 6, 2 is the intersection of the two lines. So this point right here is one of our vertices. The other vertices now, one of them is the y-intercept, the other is the x-intercept, and we already said that this x-intercept is at 12, 0, and our y-intercept for this line was at 0, 4. So that gives us those two vertices. So the only other one to find now is this boundary point of our region, and that's just the origin where the x equals 0 and y equals 0 intersect, and so 0, 0 is going to be our final vertice. Oh, and I apologize. I plugged into the wrong inequality for my x-intercept. I was supposed to use this one right here. And so if I plug in 0 for y, I'm actually going to get 8 for the x value. So this one should have actually been backed up a little bit. So let me fix that. That'll make more sense in terms of where this line actually was now too. So 1, 2, 3, 4, 5, 6, 7, 8 would actually be this point here. And so now when I actually draw this part, that's actually going to be our region. And again, that's going to mean that our x-intercept is at 8, 0, sorry, not 12, 0. Everything else there was correct, though. The intersection of the first two lines is still at 6, 2. Right? I just didn't have that other line steep enough because I was plugging into the first equation instead of the second one to find the x-intercept. Now, another thing I'm going to show you, and this will come up in the next example, is how we can actually do these using Desmos, because I think that's a good way, especially on a test, since you have access to Desmos, to help you find these points of intersection and think about these overlapping regions so that you don't actually have to graph this by hand every time. So that's what we're going to do on this one. So I'm going to graph the solution set of a system of inequalities. Notice here we've got two different systems. Everything about them is almost the same. The only difference now is this first one has a greater than or equal to on the first inequality, and the next system down here has a less than or equal to instead. Everything else about these is exactly the same. All right, so what I'm going to do, I'm going to graph all of my inequalities, and again, I'm going to do this in Desmos now. Switch over to Desmos. All right, and I'm going to graph each inequality separately here. Again, we don't actually have to solve for y because Desmos will let us graph it just like this. When you're doing greater than or equal to, you can actually just do the greater than symbol followed by the equal symbol, and it'll automatically combine those into a greater than or equal to, and then 60. And you can see now that it actually does shade that inequality for us. It gives us the line, and it's shaded above that line. Now, the next inequality in this case is 30x plus 20y greater than or equal to 100. And so you can see now, again, we have that line, solid line, everything shaded above in this case. So you can start to see where these overlapping regions are going to come in. Okay, so we've got everything above the green line and the blue line. We're looking at that overlapping region for right now. There's still 3 more inequalities to go. So the next one here, we had 10x plus 40y greater than or equal to 80. So now we have that purple line. So again, we're only looking at the overlapping region between all of these now. But again, it's still a pretty large region, everything above all three of those lines where it comes together up in that upper right-hand corner. And then the last pieces of these, we've got x greater than or equal to 0 and y greater than or equal to 0. Again, that just means everything above the x-axis and to the right of the y-axis. And so now, again, we're still looking in that upper right-hand corner where all of those regions come together. Okay, so we have to be to the right of the y-axis, above the x-axis, and then above each one of these lines. That's that entire upper right-hand corner now above all of those lines. And then if you needed to find the vertices of this one, right, we can actually just go through and find the points of intersection. So we'd have one right here. We'd have one right here. We'd have another one here. And then our last one would be down here. And again, it's everything up and to the right of those lines and those points. Now, like I said, the second system here, the only difference is that we're only looking at a less than or equal to for this first one. That's the only thing that changes. Okay, so I'm going to make this less than or equal to instead. I'm going to turn off the other ones just so we can see where we're starting from. Okay, so now instead of being above that line, now we're looking at everything below that line instead. So we can automatically see the overlap is no longer going to be in that upper right section like it was on the previous one. Okay, so now I'm going to turn on each one. So now we can see with this one, we need to be above the green line and below the blue line. Okay, so now we're looking at this kind of triangular shaped region down and in the right. And once I turn on this one now, I need to be above that. Now I'm really limiting myself, okay, because now I need to be above the purple line, above the green line, but below the blue line. Okay, so you can see in here now, I'm only looking at this region right in here. And then finally, we just need to be greater than or equal to 0 for the x and the y. All that does, again, is just make sure we're in the first quadrant, basically, but that does not change the fact that our overlapping region is still right in here now. So again, just notice that by changing that one little thing, by making one of these inequalities less than or equal to instead of greater than or equal to, it completely changes our region. When it was greater than or equal to, we would call that region unbounded because it just continues on to infinity, right? There are no bounds to what those values could be up and to the right. In this case, though, because we get this really small triangular region, and it doesn't have to be a triangle, it just has to be something where we can actually find all the points within a shape now, that's what we call a bounded region. Okay, so by just changing that to less than or equal to, we get a bounded region. When it was greater than or equal to, we would have an unbounded region instead. All right, so that's where we're going to stop here. If you have questions, please let me know. Definitely send me those questions in WebAssign. Come see me during student hours if you need to, right? Because I know a lot of these, in terms of finding those overlapping regions, can be a little tricky sometimes, but definitely reach out if you need any help, okay? Other than that, I will see you next time.